Today, we're going to talk about a technology that could literally make our world unshakable. It's called quantum sensing, and it promises something that sounds like it's straight out of science fiction. Absolute precision that can't be jammed, can't be faked, can't be broken. But to really get why quantum sensing is such a revolution, we first have to understand a hidden, fundamental flaw in all the navigation systems we rely on every single day. We all just trust GPS, right? It guides our cars, our planes, our entire global economy, really. But here's the thing. That trust is built on an incredibly fragile foundation. GPS signals are just these super weak radio waves from space, which makes them scarily easy to block or even to spoof. And in today's world, that's a massive, massive vulnerability. And this right here is the core of the problem. Even our best non-GPS systems, the inertial sensors inside fighter jets and submarines, they all suffer from something called drift. Imagine trying to walk a perfectly straight line with your eyes closed. Every tiny error, every little misstep, it just adds up. After a while, you're way off course. That's drift. These systems are just measuring their motion relative to where they started, not against some absolute universal map.
So, if all our best man-made rulers are flawed, where do we even turn? Well, the answer isn't about building a slightly better gyroscope. It's about changing the ruler itself. It's about turning to the fundamental building blocks of the universe for our answer.
And this is the central idea, the magic of it all. Every single atom of a specific element, let's say rubidium, is a perfect, flawless, identical twin to every other rubidium atom in the universe. They don't wear out. Their properties never change. They are governed by the fundamental constants of nature. This makes them, quite literally, the ultimate universal standard for measurement. And that realization creates a whole new paradigm. A classical sensor, it gives you a relative measurement that drifts away from reality over time. But a quantum sensor, because it's referencing a perfect atom, gives you an absolute measurement. It's really the difference between guessing how far you've walked by counting your steps versus just opening your eyes and knowing your exact coordinates on a permanent grid. And maybe the most important takeaway is this. Quantum sensors never need to be calibrated, ever. The reference point, the atom itself, is perfect by its very nature. So this isn't just an improvement, it's a complete game changer in how we think about precision and reliability. We've all heard the story about Newton and the apple, right? That helped us figure out classical mechanics. But to measure things with this new level of precision, we've got to go way, way smaller. So the question becomes, how do you actually ask an atom about the world around it? How do you get it to talk to you? Okay, the process is called cold atom interferometry, and it is mind-bendingly cool. First, you use lasers to chill atoms down so cold they start acting like a single unified wave. Then, and here's the quantum magic, another laser splits each atom so it travels down two separate paths at the exact same time. It's a state called superposition. Finally, you bring those two paths back together. If the sensor moved at all, even a microscopic amount, those paths won't line up perfectly and you can measure that interference pattern. You're basically using the atom itself as the world's most sensitive motion detector. And listen, this isn't just theory or science fiction anymore. This jump from the lab to the real world is happening as we speak, and it's having immediate strategic impacts in some of the most intense environments on the planet. So let's start with the first major application, navigating submarines. As you know, GPS can't penetrate water, so subs have to rely on those old inertial systems that drift. To correct that drift, they have to risk coming to the surface to get a GPS fix, which is the absolute most dangerous thing they can do. It totally exposes their position. Quantum sensors completely rewrite the rules of that game. A submarine can now use a quantum gravimeter, a sensor that measures tiny shifts in gravity, to create a perfect 3D map of the seafloor and navigate by it, all while staying deep and hidden. They can even use quantum magnetometers to detect the faint magnetic signature from another submarine's hull. It is a massive, massive leap forward in undersea stealth and awareness. And it's not just under the sea. Up in the skies, the need is just as critical. GPS jamming is a growing threat, and aviation desperately needs a reliable backup, an unjammable alternative. Quantum sensing is that alternative. And the proof is already here. This is just incredible. In a recent Boeing flight test, they flew for 4 hours with the GPS completely off. The quantum navigation system kept its position accurate to within tens of meters. A cutting-edge classical system on that same flight, it would have been off by as much as 20 kilometers. I mean, that's the difference between landing safely on the runway and ending up in a totally different county. This proves the tech isn't just coming, it's here. So it's no surprise that this technology is being rolled out across the entire defense sector. We're talking about everything from unjammable guidance for missiles to precision navigation for satellites in deep space way beyond the reach of GPS. Quantum sensing is quickly becoming a cornerstone of national security. But the potential here just explodes far beyond defense. In mining, you can use these sensors to create incredibly detailed 3D maps of ore deposits buried deep underground. In medicine, they're paving the way for revolutionary brain scans, so sensitive you could see individual neurons firing in real time. And for self-driving cars, this is the technology that will offer perfect navigation through dense city canyons and tunnels where GPS signals just die. So, what does this all add up to for the next decade? We are truly on the verge of integrating this technology into the very fabric of our society, building our future on a new foundation of unshakable precision. And there's serious money behind this shift. The market for quantum sensing is projected to hit $10 billion a year by 2035. This is no longer a niche academic project. This is the next major global infrastructure build-out. And the roadmap is already clear. By 2028, we're going to see it in critical areas like aviation and global shipping. By 2030, the tech will be small enough for autonomous vehicles. And by 2035, it will likely be the silent, unjammable backbone running our global telecom and financial networks. When you step back and look at the big picture, we're moving from a fragile, relative world to one that's built on an absolute, unjammable foundation. For the first time ever, our most critical tools can measure our world against a perfect reference, one that simply cannot be disrupted. And that just leaves us with this incredible open-ended question. I mean, these sensors are so sensitive, they might be able to detect things like gravitational waves, maybe even dark matter. They can map the firing of our own neurons as we think. So as this technology gets smaller, cheaper, and more common, you just have to ask, what fundamental secrets of the universe, or even of ourselves, will we finally be able to unlock?